everyone, I'm Napur and I am a math fan. So this week's math video is going to be about the topic of completing the square. Completing the square is one of the three methods to solve quadratic equations. Just a quick recap, quadratic equations are equations where the term of the highest degree has degree 2. And the three methods are completing the square, the quadratic formula, and factoring. People generally seem to find completing the square the hardest of all of the three, just because it has a lot more steps than the other two. But in some cases, the quadratic formula is harder to remember and even harder to apply than completing the square. And factoring cannot apply to all quadratic equations. So it's important that everyone knows how to complete the square. Now I'm going to demonstrate completing the square over here, just show you all the steps. And then I'm going to explain each step in more detail. Sounds good? So we have this. Step number 1 is to move all the constants to the other side of the equation. In other words, for this one, we're going to subtract 4 from both sides. Our second step is where this method gets its name. We're trying to turn this into a perfect square trinomial, which is a trinomial that can be factored into something of the form ax plus b the whole squared. To do that, we must add 9. Why 9? I'll explain that a little later. After that, we can just shorten this into x minus 3 the whole squared is equal to 5. After that, we must take the square root of both sides to create x minus 3 equals plus or minus the square root of 5. Wait, you might say. You said take the square root of both sides, so then where did this thingy over here come from? Yeah, that just comes because there's always two things that's squared to every real number. Always two things, except if the number is 0. But for everything else, yes. And then of course we just have to finish this off. Isolate the x by adding 3. And we're done. Okay, now let's go over the steps. Step 1 was move constants to the other side. This step is pretty self-explanatory. It's not very hard to understand. It's probably the second step that's more complicated. Complete the square trinomial. Step 3 is factor, and step 4 is take the square. And then the last step is rearrange. Steps 1 and 5 don't require much explanation, so I'll just explain 2, 3, and 4. Now for an explanation of step 2, completing the square trinomial. How exactly is one to do this? Suppose we have the very nice expression x squared plus 8x. We want to turn this into a perfect square trinomial. So we have to remember something. Don't you remember that when you expand something of the form x plus a the whole squared, you get x squared plus 2ax plus a squared. Now we take a careful look at this. Which term seems to be missing? We have the x squared term, we have the x term, so it must be the a squared term that we're missing. To add back the a squared term, we need to know what a is. So how do we know what a is? We just need to compare the coefficients over here. 8x is equal to 2ax. So a is going to be equal to 4. That makes a squared equal to 16. So then we just need to add a 16 over here. Does that make sense? Okay, so we've gone over step 2. Now we need to go over step 3. Step 3 actually isn't that hard. if we have our very nice looking x squared plus 8x plus 16, all step 3 demands is that we just factor this back from our x squared plus 2ax plus a squared into our x plus a the whole squared. And by doing that, we just note that this a has to be the square root of this. So we come up with x plus 4 squared. That's nice. Step 3 really wasn't that hard. Now, step 4 is about as complicated as step 2. Suppose we start off with something that looks like this. We say we want to take the square root of both sides, but we're not just taking the square root. We're actually thinking a little one step up higher. So we know that seeing as 3 is not equal to 0, there are exactly 2 things that square up to 3. These things are the square root of 3, but we also remember that negative the square root of 3 also squares up to equal 3. The negative signs cancel each other out because that's how multiplication works. Now, seeing as these are the only 2 things that square to equal 3, then this x minus 2 must be equal to either one of them. So we represent that with adding this plus or minus over here. It means positive or negative the square root of 3. So then, of course, we can just do step 5 and solve. So let's try and solve another thing, keeping all these steps in mind. This one is going to be x squared plus 7x plus 6 is equal to 0. So step 1, move all our constants to the other side. I don't think I made this clear enough, but you actually don't have to do this. It just makes things a little easier. Our second step is to complete the square trinomial. The 2ax term is equal to 7x. So we can figure out that a is going to be 7 halves. So a squared is going to be 49 over 4. So thus that's what we need to add to both sides. Yeah, I just converted the negative 6 into negative 24 over 4 for ease in addition. Then we just need to factor. We know that this is going to factor into x plus 7 halves squared because we just figured out what this a over here is going to be. And then we can just add this to make 25 fourths. Then what we do is take the square root of both sides to get x plus 7 halves is equal to plus or minus 5 halves, because either 5 halves squared or negative 5 halves squared equals 25 over 4. Do not forget the plus or minus. It is very important. Then we can just subtract 7 halves from both sides and then simplify to come up with an answer that looks prettier than negative 7 halves plus or minus 5 halves. So, I hope this made sense to you. I hope my video helped you understand the idea of completing this grammar. If not, I'd love to clarify, so just comment on this video if you don't understand something. Anyways, thank you for listening. Bye!